A pleasant morning to the young and enthusiastic learners. I'm Dr.Shobha, Principal, Associate Professor and Head of the Department of Corporate Secretaryship, KCS Kasinada College of Arts and Science, Chennai, here to present Interpolation and Extrapolation. Now for the introduction. The technique of interpolation and extrapolation are extremely helpful in estimating the missing values or projecting the values. The meaning goes as follows. Interpolation refers to the insertion of an intermediate value in a series of items, whereas extrapolation refers to projecting the future values. So, when you try to find out a value within the series, it is interpolation, and when you try to identify a value outside the series, it is extrapolation. Importance of interpolation and extrapolation. It helps to know a particular type of information. It also helps to know a part of data which is destroyed or missing. Methods of interpolation and extrapolation. They are as follows: the graphic method and the algebraic method. Within the algebraic method, we have the binomial expansion method, Newton's method, Lagrange's method, parabolic curve method. We shall be seeing the algebraic methods with regard to binomial expansion, Newton's method and Lagrange's method. Graphic method. So this is the simplest of all the methods of interpolation, where you just draw a graph in a graph paper and plot the points, and the lines are joined together, and the curve or the straight line is extended to interpolate or extrapolate the values. Algebraic method is one where we use formulas for finding out the values to be interpolated or extrapolated. Now for the binomial expansion method, we give the formula as follows. A simplified way. For example, if we begin with y5, it is y5 5y4 by 1 factorial plus 5 into 4 y3 by 2 factorial minus 5 into 4 into 3 y2 by 3 factorial plus 5 into 4 into 3 into 2 y1 by 4 factorial minus 5 into 4 into 3 into 2 into 1 y0 by 5 factorial, which is equal to 0. So it starts with plus y5 minus plus minus plus minus and so on. So this 1 factorial is nothing but 1 into 1, 2 factorial is 2 into 1, 3 factorial is 3 into 2 into 1, 4 factorial is 4 into 3 into 2 into 1, and 5 factorial 5 into 4 into 3 into 2 into 1. So this is your formula for binomial expansion method. Now the Newton's method, where it is given by this formula y0 x delta 1 by 1 factorial plus x minus 1 delta 2 by 2 factorial plus x minus 1 x minus 2 delta 3 by 3 factorial and so on. Going to the Lagrange's method, it is given by this formula y0. Since you start with y0, you do not have x0 in the numerator. It is x minus x1, x minus x2, x minus x3. And in the denominator, we start with x0, x0 minus x1, x0 minus x2, x0 minus x3 plus y1. Here we will not be having x1 in the numerator. So x minus x0, x minus x2, x minus x3, and in the denominator we start with x1. So x1 minus x0, x1 minus x2, x1 minus x3 and so on. Now going on to some problems under interpolation and extrapolation. So here your given data is in equal intervals. 1961, 1971, 1981, 1991, 2001. So they are advancing in equal intervals, and since they are advancing in equal intervals and what we have to find is also in an equal interval, we are using the binomial expansion method. So, as per the binomial expansion method, we give the values y0, y1, y2, y3 and y4. So, our formula starts with y4. y4 minus 4y3 by 1 factorial plus 4 into 3y2 by 2 factorial minus 4 into 3 into 2y1 by 3 factorial plus 4 into 3 into 2 into 1 y0 by 4 factorial, which is equal to 0. So we substitute the values in their places and we find y2. A similar problem where the values are moving in equal intervals. 1987, 88, 89, 90, 91, and you are to extrapolate for 92. So values are moving in equal intervals, and what we have to find is also in an equal interval. Here it's y0, y1, y2, y3, y4 and y5, which we have substituted for the profits. So our formula starts with y5 and it goes on. It starts with plus y5, then minus 5y4 by 1 factorial, then plus 5 into 4 y3 by 2 factorial, again minus 5 into 4 into 3 y2 by 3 factorial, and so on. Substituting the values, we find the value of y5, which is 81. Now, going on to another similar problem which has been repeatedly asked in the university examinations. So, here they have asked you to find the value for the year 2000 and 2002. The values we first see is 97, 98, 99, 2000, 2001, 2002, 2003. So, now they are in equal intervals, and what we have to find is also in equal intervals. So, we still stick on to the same formula, the binomial expansion method. So, we have two missing values, so we have to solve it with two equations. So first we take equation 1 with y0, y1, y2, y3, y4 and y5. So with this we write our equation y5 minus 5y4 by 1 factorial plus 20y3 by 2 factorial minus 60y2 by 3 factorial plus 120y1 by 4 factorial minus 120y0 by 5 factorial, and we solve it. We arrive at the value of y5. Similarly, we write another second equation with y1, y2, y3, y4, y5 and y6, leaving off the first value. So with a similar equation, we get another equation, and then we try to solve both the equations and we arrive at the value of y3 as well. Now going on to a similar situation, values are moving in equal intervals, and what we have to find out is also in an equal interval for 2006. So you all know by now we would be applying the binomial expansion method, since given values are moving in equal intervals and the value we have to extrapolate is also in equal interval. So hence y6 is arrived at using the binomial expansion method. Now going on to the next one. We have the given values 5, 6, 9, 11. So you are asked to find for the 10th month. So the given values are in unequal intervals, and what we have to estimate is also in an unequal interval. So we use the Lagrange's method. So when the given values are in unequal intervals and what we have to find out is also in unequal intervals, then we have to use the Lagrange's method. So for the x values, we give the reference values x0, x1, x2, x3, and similarly for y0, y1, y2 and y3. Going on to the formula, we start with y0, x minus x1, x minus x2, x minus x3 divided by x0 minus x1, x0 minus x2, x0 minus x3 plus y1 x minus x0, x minus x2, x minus x3 divided by x1 minus x0, x1 minus x2, x1 minus x3 plus y2 x minus x0, x minus x1, x minus x3 divided by x2 minus x0, x2 minus x1, x2 minus x3 plus y3 x minus x0, x minus x1, x minus x2 divided by x3 minus x0, x3 minus x1, x3 minus x2. So once your formula is correctly framed, then you just have to substitute the values and arrive at your answer. So here again you have the values minus 1, minus 2, 2 and 4. So though they are moving at equal intervals over here, and you have to find the value for x equal to 0. Here after 2 it is advancing in an unequal interval. So hence, since the given values are in unequal intervals and what we have to find is also in an unequal interval, we are applying the Lagrange's method. And we arrive at the value of the answer as minus 1.99. Now, going on to the next problem, the given values are in equal intervals. What we have to find out is for x equal to 2.5. Given values are 2, 3, 4 and 5. So they are moving in equal intervals. But what we have to find out is an unequal interval. There we use the Newton's method. So when we go in for the Newton's method, the given values are in equal intervals and what we have to find out is an unequal interval. So here we substitute the values with x0, x1, x2, x3. Similarly y0, y1, y2 and y3. Now it is the method of differences, Newton's method of differences. So first we have 16.3 in the y value minus 14.5, which gives you 1.8. Then 17.5 minus 16.3, which gives you 1.2, and 18 minus 17.5, which gives you 0.5. Then the second difference. So this was our first difference. Now we go on to the second difference. So from the first difference we arrive at the second difference. 1.2 minus 1.8 is minus 6. 0.5 minus 1.2 is minus 0.7. So we get the second difference. And from the second difference we move on to the third difference. Minus 0.7 minus of minus 6 will become plus 6 plus 0.6. So it is minus 0.7 plus 0.6, which gives you minus 0.1. Now this is your table of differences. Now you are supposed to find out the value when x is 2.5. So 2.5 minus the previous x value, which is 2, divided by the height. The height of it is going to be equal, so it is 1. That is, the difference between 3 and 2 is 1. So it is 0.5 by 1, which is equal to 0.5. Now going to your formula, you're going to substitute the values. Y0, the first value in y is y0, plus the x value that you found out, 0.5, into the first value in the first difference column, 1.8, divided by 1 factorial, plus again 0.5, the x value, into x minus 1. So 0.5 minus 1 into the second difference column first value, minus 0.6, divided by 2 factorial, plus again the x value 0.5 into 0.5 minus 1, 0.5 minus 2 into the third difference value, the first value, minus 0.1 by 3 factorial. And then you solve this equation and you arrive at the answer 15.469. A similar problem where You have the values for 1980, 1990, 2000 and 2010. The values are moving in equal intervals, but we have to find out for 1996. So what we have to find out is in unequal interval. So it is going to be, x is going to be 1996 minus the previous value 1990, which is 6, by the height. The height, wherever you try, it's going to be equal, it's going to be 10. So 6 by 10, which is 0.6. And we have created the differences table, that is y1 minus y0, y2 minus y1, y3 minus y2. And we got the first difference. Then 3525 minus 3509, then 3542 minus 3525. We get the second difference. Then 17 minus 16, the third difference, which is 1. Now substitute these values in your formula as we did in the previous sum and arrive at the answer, which is 27,597.536. So this is for your interpolation and extrapolation, where you identify the missing value within the series or outside the series. Thank you and have a smart and happy learning.